Namaste everyone. I Sriom Das from Trim Glastrier is here to elaborate about our solution prototype. So before directly getting into the solution prototype, I must introduce you to our problem statement. So our problem statement was released by SIH with the student with the problem ID of 1289 and with the title of projection of extent of inundation corresponding to the forecast flood level in a river. This was a problem statement released by the Ministry of Jal Shakti on the SIH problem ID. So, after the problem ID we have seriously analyzed the problem ID and we came to know that in the CWC website, the people have already developed a model where the occurrence of flood is already predicted. But the main issue what government is facing is about the severity of the flood. Like, let's say there will be a flood at the Brahmaputra river. So how much area is going to be affected by that river, that thing is not done yet. And by predicting that particular thing, we can also automate our disaster management system and our relief system. So for that purpose, government have given us that problem statement. So now we have chosen that problem statement and we decided to go through a particular way of solution. Okay, so let me elaborate my solution. Like every solution, our solution is no different. Our solution also has the users as the cornerstone, as it is already mentioned in the program that our users are going to be the government officials. So we are developing a single page multi-layer interactive web application for them. Yes, a single page multi-layer interactive web application. So how will that web application go? Let me give you the walkthrough of a user. Let's say I am a government officer. I will first click on that website, and once I click on that website, it will ask me for authentication, because we don't want everyone to access the data. We only want the authenticate government officers to get the data. So once the government officer is authenticated, he will be shown a big map of India with every river distinctly marked above the map. Once that map is done, we will be taking the data from CWC website to our website where there is a chance of flood occurrence in the map. After that data is also gathered, we will be showing the data on our map at the live moment. So let's say there are 3 points in India during the monsoon season where there is a chance of flood. Those are our Brahmaputra, our Mahanadi and our Narmada Nadi. So when the user will open that application, he will see 3 points on the map of India where those 3 points are marked. Then he can zoom into each point to get to the deeper level. So let's say he has chosen the area Mahanadi. So once he starts to zoom in the area Mahanadi, he will then see the state Odisha, then he will see the district Cuttack up to a maximum zoom limit. So once he has totally zoomed into the limit, the place where the zoom is finally end, there will be a pointer above that limit. So once reaching to that point, he can click on that pointer. Before that, the pointer will not be available to click, but once reaching to the maximum zoom limit, he can click on that pointer. So once he click on that pointer, there will be 3 concentric circles representing respective things. The first one will be the red one, or the innermost one. The medium one will be the orange one, and the most outer one will be of a yellow. What does those 3 concentric circles represent? Those 3 concentric circles represent the severity of damage across areas and the radius of the damage. So the red area will show the maximum damage area, the orange area will show the moderate damage area, and the yellow area will show very lightly damaged area. And also when we click on that particular pointer, there will be an row on the left side that will be showing the radius of the red area, the radius of the orange area, and the radius of the yellow area, according to which the government officers can prepare well before and take care of the system of the relief management and evacuation team. So once they know that these areas are going to be affected, they can easily evacuate people from them and take them into a place where there is no chance of any effect of flood. Okay, so now this is the user type. Now how does the machine does its work? So to show the data to the user on the pinpoint time, we have to start the working very way before. So we will be developing an AI/ML based GIS application that has trained on vast amount of imagery data and statistical data. So why two type of data is needed? Statistical data will help us make the prediction better, where the imagery data will give us the severity of the flood. So on basis of that, we would have trained two models. One is the statistical data prediction model, another is the imagery data prediction model. For the statistical data, we will be getting our inputs and the datasets from CWC, NRSC and much other websites. And for imagery data, there are many government websites and also Google Earth Engine, from which we will be gathering the data. After gathering the data, we will divide the data into two datasets. One is flooded dataset, another is non-flooded dataset. So on those two datasets, we will be training an AI model. Okay, once that AI model is trained, we will be implementing that AI model to our program. So now the AI model is implemented to the program, but how would our program make the prediction? That's the question. So let me answer it also. To make the prediction, our program will take the data of 3 days. So we would have chosen many parameters for that, like rainfall data, soil strength, water gauge level, river speed, moisture across the area. So all those 5 to 6 parameters, and on the basis of previous datasets, our AI model is trained. So on the same dataset, we will be designing another dataset where only and only the data previous 3 days will be stored. For let's say today is 1, so there will be the data of 29, 30 and 1. That's a different dataset. So from these 3 datasets, this data will be given to the pre-trained AI model. So we have already trained the AI model using the past historic dataset. Now we only have the dataset of previous 3 days, and from that 3 days we will be giving as input to the data our AI/ML model, and that AI/ML model will give us the prediction. So let's say on 30 and 31st and 1, all those 3 days data are given to the AI/ML model. Now the AI/ML model will analyze the data, going through back and altering through different kind of data, and it has predicted that there is no chance of flood, and even if there is a chance of just water bending a bit, there will be not any damage. So now the data of last day, that is 30, will be deleted. Now there will be the data stored of 2, 1 and 31. Now again inputting the data of 2, our model will predict yes, there is a chance of flood, or no, there is no chance of flood. So by working like this, our project will help predicting the severity of the flood. Now for everything we have used different kind of tech stack. For the web development, we have chosen AngularJS and Node.js. For the databases, we have chosen SQL for training our AI/ML model, and MongoDB for storing the data of 3 days and inputting to that to the AI/ML model. Then for the GIS model, we have chosen many different libraries of Python. Those are TensorFlow, Skitlearn, GeoPandas, GDL, and NumPy for raster data collection and improvisation in an array, and many more. And for more optimum solution and pinpointed precision, we have chosen 2 more software, so that ArcGIS and QGIS. By using those 2 models, we will be predicting the pinpointed area where there is a chance of getting the flood. So after all this been said, now let me tell you the good things of our project, that how it will help the government. First, it will save life of million people. The first thing, it will help people knowing about the flooded area so that they can be easily moved out to from another place. Second thing, it will help government in pre-evacuation procedure. They now know how much people to be evacuated from where to where. So by utilizing that process, government can easily evacuate people. Third, relief management automation. So now the government knows that this much people is going to be that area. So now if 100 people are there, government is already aware that we just need to prepare the food for 100 people, not about the 1000 people. That's a help in relief automation. Fourth thing, it will help government in reducing the loss of many fields. How? Let's say there is an area where the flood severity is high, so the government will prohibit building any kind of bigger or high-end projects that will cost a big financial cost to the government. By that, government will save a lot of money at that position. And finally, it will help our economy in growing, because if government has found that on this particular area there is always high flood severity, so government can work upon that and do some precaution to stop the flood getting more and more dangerous in that area in future years. So these are the some key benefits of our solution. So now finally come to the last stage, why a solution is better than everybody else. So our solution is only 3 to 4 clicks away from knowing the severity. You just need to authenticate yourself. That's the first step. And in the second step, you have to just zoom into the map and get to the pinpoint. In the third step, you just have to click on the pinpoint, and all data on the map and as well as in the statistical manner will be shown to you. Now, the second best thing about our product is our product will give you concentric circles at every flooded areas, which will be helpful in finding which area will be affected how much. So previously we are only aware about the project that's going to be happen or the flood that's going to be happen, but now we are also aware about the how much area is going to be affected. That kind of model is developed by us, and our model will be showing the precise data about that according to the radius, according to the topological area. Considering all those facts, we will be showing you the output. So there is a high chance that every time a new data is fed into the model after the checking, our machine learning project will be getting better and better, and the GIS application of our project will be enhanced. So now if I have implemented that project in the year of 2023, so in the 2025 the preciseness of our GIS model will increase drastically, because the new data is fed to it and it will absolutely learn from the data. So these are some key benefits of our model. So now, if everything is clear to everybody, I would like to conclude this video, and hopefully I am thinking that everyone has clearly understood our project. And if there any further doubt, please feel free to contact us. Thank you.